Okay, my name's Nigel Ashworth. I'm a solution architect at F5, and most of my role is doing DNS for service providers. And I travel around the whole of Europe, Middle East, and Africa. And I either present or I go on site and we do proof of concepts. And I generally discuss how and where DNS is going, what it's actually going to be doing, and some of the things that catch people out. First of all, also, I've got to present in English. I apologize about that. My agenda. Well, I've got 35, 40 minutes. What I would like to cover is all of that. Lots of things about DNS, but we've only got 35 minutes. So probably cover maybe about 5 or 6 topics in terms of some of those areas there. If you want to talk about any other topics, I'll be downstairs on the F5 stand, and we can have a chat and go through some of the other areas which may interest you. Okay? So, first off, what's driving DNS? You know, why do we need to have DNS as a highly available system? What's causing us to actually look at DNS and re-architecting some of the DNS environments out there? Well, actually, when you look at it, it's really quite simple. If you look at what you have in your house today, if you go and have a look at how many IP addresses you use generally, I did it at my house and one of my friends' houses, and I ended up with 25 IP items or endpoints just sitting on my actual internal house network. We look in here, we've got 40, 50 people. I guarantee you, you're utilizing at least 50, 60 IP addresses in here for your handsets and your mobiles and everything else. So the explosion of items that can actually generate DNS requests is just massive. In terms of the general items here, if you look at some of the researchers, and the researchers talk about what's exploding, well, it's the number of items that we have in our hands and in our desks and at our home that our kids use and the things that we use at school generally. And whatever you like to say, they're turning around and the explosion is very, very, very steep indeed. If you look at the applications side of it, from enterprise orientation, they're doubling every 2 years in terms of that environment set there. If you also look at sort of some of the actual things which are driving it from a service provider land, well, it's the number of the connections that we have that come through on a regular basis. But also other things which are driving some of the DNS are scaling some of it, but securing some of it. You don't want to be seen to be your cache as part of an attack onto the actual internet and those components of it. So generally, what we're seeing is large numbers of connections and spikes for a number of reasons. They might be general requests going out there, but we're also seeing the malware and the attack components coming from within the actual user environment set there. If you look at some of the items down the right-hand side here, what you'll see is 1 or 2 of the items which are sort of DNS related, but quite a lot of it starts with DNS. So all our connections that we have anyway, it's always normally a DNS request that goes out there. So it's part of our acceleration, it's part of making our user experience fast in that environment set there. So DNS has got a number of things to play and role, not just the actual availability of it, but also the actual speed that we actually do the resolutions at. But there's a whole load of other things that people want to do with it, which really shouldn't really. What I'm talking about there is protocol misuse, abuse, and those types of things which happen. We'll talk about those as we look at 1 or 2 of the slides a bit later on. Some use cases. What drives the actual use cases components? Certainly, as I work in the service provider environment set here, I would say there's mainly 3 main areas which I do work in, and we do some scaling factors on it. First one sits in the actual cached environment, LDNS, transparent cache, resolver, all of those components that sit there. Also, quite a lot of people these days are starting to look at the infrastructure and the components here. And how do you actually do GGSN or packet gateway load balancing and traffic management to those ones as well, and high availability in that area. So that's sort of the second area which comes up on a regular basis in terms of that environment. Interestingly enough, this is normally very high performance in terms of requests and the thing. This is pretty low performance, but high functionality in terms of those types of environment sets there. Sort of the third area is authoritative in terms of that area, and either being a local environment or sort of more hosted environment sets there is quite a common environment there. So there are 3 main areas. LDNS, cached environment sets there. If I look at most of my engagements over the last 6 to 9 months, I would say probably 80% has been based on that environment there. People are looking specifically at how do you actually provide some DNS security, but also once you've provided the security, how do you also provide the performance components there? Okay? So huge amounts of raw performance and raw scaling required on that environment. Authoritative. How do you survive some of the attacks that are out there, reflective attacks and components there? We'll talk about that in terms of scale in a short while. And I talked a little bit about the infrastructure environments there. But those three are the three main ones which work on a regular basis. But actually look at what we do. Think about your DNS architecture that you have today. What does it look like? Maybe it starts with something like a user sitting on the outside. It actually comes into the actual system, but it goes through a firewall to a DNS server, from a DNS server maybe to a load balancer, and then maybe a hidden master in the back end of another firewall. We'll look at that architecture in a minute. That's what we've been designing with for the last 10 years. But things are kind of changing in that environment. And as you go around Europe, Middle East, and Africa, and I talk to the people what they want in terms of an architecture component, they're looking at how do I re-architect it to get, one, the scale that I need, but also how do I actually get some consolidation environments down there. So if you accept that applications are growing massively, the amount of data and the volume is growing massively at the same time, and we are generally carrying more general phones and items which can do a DNS request on it, and doing more of them on a regular basis, then this architecture which we have here, which I suspect is in most of your environments, is going to creak. It's going to have some problems with it. And commonly what we do is we look in this environment here, and you'll find that actually it's the external firewall component here. Anybody had much experience of putting UDP through firewalls today? Yeah, there's 1 or 2 nods there. Okay. It just doesn't happen particularly well. Okay. If you go and put DNS onto the actual internet directly, it again has some issue sets with that in terms of the CVEs which come out on a regular basis. So how do you actually take that sort of conventional DNS thinking, that architecture, and change it and do something different and new that's going to actually allow you to scale and actually provide you with some of the security aspects of it? This one's for an authoritative one, but I've got a couple of slides, or slide next looks at the cached environment there. But the idea in terms of consolidation is that what we're starting to see is the ability to have a platform which can actually allow you to actually take both the firewalling of the DNS and the actual DNS itself and consolidate those components down. So where you would have traditional firewall, load balancer, and DNS servers, those all become one in that environment. You still keep your hidden master in the back end, that's a given, and your management side of it. But predominantly, what it's saying here is that you can consolidate. If you can consolidate that environment, then the scale actually then starts to become realistic. So if I look at DNS RFP from 10 years ago, 2,000-3,000 resolutions per second. If I look 2 or 3 years later, it's about 10,000. And then there was a change from vendors generally that said, oh, we need to use caching. We can go to 100,000. So actually in the last year or two, when I do my testing, I have a test rig in the UK which I use. Last year I was testing to 1 million resolutions per second. And that was proof of concepts and ideas being put down on paper for their end customers. Last week we did 4 million. I have a request for by the end of the year to show 10 million as a request on that environment. So those need to be demonstratable, and you need to be able to scale it, and you need to be able to have the environment set up there for it. Okay. So one of the things there is also on the scale is that you're not really talking about scale for the number of resolutions for the users, but it's actually scale to actually protection. How can you actually mitigate against that in-house attack, all those components there? So, just another slide. I left this one in there here for caching environment so that it was complete both for authoritative and for the caching environment set there. But the principle is exactly the same. You can consolidate down in terms of the component sets there. So should you have a firewall in front of your DNS? Come on in, gentlemen. Should you have a firewall in front of your DNS? Most of the time we put firewalls in there, but I keep saying it limits your design and your architecture for longer terms. How do you actually get around it? Well, You can consolidate the components. But what should be in a DNS firewall? What of all the components should be in there? This is my list, by the way. Oh, I've got a couple more slides, first of all. We'll get onto the list of what should be in a DNS firewall. But what do people use today to actually protect their firewalls? What do they use today to protect DNS? Well, commonly, the actual things that they actually utilize is actually ACLs or none. You can see the slides later, they'll be provided to you. But generally, you'll find that there isn't that much protection in front of there, just basic ACLs. And if you've got port 53 already pushed through, then it's getting back to your DNS server and the server at the back end of it. So this is my list of things which, when I'm doing a design or an architecture, I would commonly do for looking at DNS environment. If you can use Anycast, please use it. It's simple. It's not part of any product or anything else, but it's just if your network supports it, then it's an obvious thing to utilize. Next thing is, if you actually look at what happens in terms of general attacks and components there, you need a filter of some description. A really basic filter, not complex, very simple. Validate the protocol. Take DNS and do a high-speed sweep of it and make sure that when you actually do that, you just make the packet is complete. It's not made of rubbish, or it's not an attack component there. So do protocol validation. Just check the packet is the right format, the right area, before you pass it back into any service or services. So that's what I mean by pre-filter in that environment there. The very first thing you do, protocol sanitize it. Make sure it's the RFC compliant component. Packet inspection. Let's have a look at maybe some of the actual packets that are passing forward. If you see 500 requests for the same domain coming through per second, hey guys, something's wrong, okay? Somebody's doing something to your system that you shouldn't be. So if you have the ability to actually inspect every packet, not just at the network layer, but actually what's inside the content of that request, that DNS request, then you can make decisions based on it, and you can choose either to let it through, rate limit it, quarantine it. So you can do lots of different things to it. But you need a very high-speed packet inspection engine component. Performance. Performance is, these days, quite often done in terms of CPU orientation. But actually, what you'll find is that DNS these days is starting to move between both the software and hardware. So if you can actually have a server or a delivery controller delivering you maybe 1 million requests per second, sounds a lot, but actually you'll find a lot of people utilizing it these days. But actually, if you change that and put it into hardware components, quite often you can get 5 to 7 times that performance just by actually utilizing a hardware FPGA or a chip inside the actual units there. And that's generally what we're starting to see, is that the actual hardware is actually hardware accelerated as well as software orientation. So when I say performance, I mean looking at how your actual software is orientated and relative to hardware. One of the other things which I'd like to see in a DNS firewall commonly is the way that the operating system is generally utilized. Linux, bind, and everything else. I came from that background a long time back. I kind of moved over into F5, and I needed an operating system, we use an operating system, which actually allows us to scale very linearly. So if I take 30 CPUs or 32 CPUs, I get linearly 32 CPUs worth, and I can scale it very, very linear on that aspect of it. So as I actually put in extra blades or other components on it, then actually what happens, it scales immediately, but you don't have to reconfigure it and reset it up. Why is that interesting? Well, if I did one of the ones in Norway, we did some work for the skiing up there, and when they got to the Olympic skiing, they were running at about 10 gig. And when they're running at 10 gig, they turned around and said, we need another blade. We just put another blade in, went to 20 gig in terms of performance. So you can scale it out very easily, very simply. You don't have to change your infrastructure, your cabling architecture and the components. You can just scale it by actually adding more CPU or capacity into the unit sets there. So that's what I'm talking about in terms of the scaling for resolution in that. And that works both for authoritative and also for caching as well. DNSSEC and DNSSEC validation. How many people do you think actually utilize DNSSEC out there today? One? You utilize it? Do you validate it? You validate it, good, okay. I've just recently been in the Middle East, and there's a country out there that doesn't has DNSSEC at all. They haven't signed the top end of it. But they only have 1 or 2 exits out onto the internet, and somebody managed to cache their poison their cache going off into the internet. They basically managed to get hold of every single person's credentials and components on that. If they'd had a DNSSEC and they were validating it, it wouldn't have happened. Okay? We turn around and we say that it should be in there by default, and certainly the validation should be switched on. But it is a two-edge, it works both ways. So the country that has done the most, I suppose, in terms of DNSSEC is people like Sweden. And they've had it on for many years now, but they find that people use it for amplification attacks in their domains, and they actually utilize that component of it. So from an authoritative side, it should, you just need to be careful on it. But from a service provider environment and caching, validating absolutely should be there. Reporting, validation. Okay? One of the components is that you need historically to understand what's going on. There's a great story here which happened with one of the customers. They went and started to putting all of these components onto their existing DNS infrastructure, and the performance levels went from down, 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 down. So as you add on all of these types of things, actually your performance levels generally will go down in terms of the number of resolutions there. So if you log everything, okay, and you report on everything, which some governments ask you to do, then expect the CPU utilization to go up and your number of resolutions to go down. Okay? It's just part of the design and the architecture. But you need to know, as you put reporting and automation on, what impact it will have in terms of the real world. Talk about that a bit later on. There's always the need to filter. There's different types of filters you can apply. You can put a host name filter on if you're familiar with WebSense and that type of technology. I think it's absolutely great. It should be utilized in a DNS deployment. Or you can make your own host names up, and you can pick them up from maybe governmental environments that want you to ban certain websites. A lot of that is done in the Middle East in terms of environment. There's also those dynamic ones, those malware components that put up a DNS site, and then you want to take it out. So RPZ is a great way of getting a feed in to be able to stop those types of requests coming through to your actual network. And also there's IP reputation. If you know that it's an open resolver, or if you know that it's actually a botnet, then why are you actually asking it to actually be a part of your network? Why can't you actually stop those requests going through? So there's 3 main areas of filtering which actually are very useful in terms of a DNS deployment. One which is coming online these days is DNS scrubbing, and the idea that you can actually look at a DNS request and actually either put it to TCP, or you can do ideas like a cookie for DNS, and as you do that, you then actually get some context about the user rather than just having a UDP packet, which allows you to arrive there. You have no idea who it is other than an IP address and a query. Hardware sizing. I talked a little about this a bit earlier. Actually, it's pretty important, because a lot of the time you'll go to vendors, and when you talk to the vendors will say it'll do 1 million, it'll do 2 million, it'll do 10 million. But actually, what will it really do when you actually put all of the actual features on in terms of your logging, your actual filtering, and all the other components that you want to do? Okay? So sizing the hardware and being able to size it appropriately and scale it easily is fundamentally a very big important thing, especially in service providers where you look at your architectures only once every 3 years, maybe 4 years, in terms of your deployment roles. Last item. If you take something out that has a firewall in it, and you're going to put something else in front to replace it, you need to pass the audit. Okay? So actually, you need to make sure that you're passing your audits on a regular basis. So if you're not ICSA certified, then don't expect to actually replace it, replace a firewall and not pass an audit. It's fundamentally, you must be able to pass it. So this is sort of my anatomy or list of things that I work to. There may be 1 or 2 more that we'll add in the next presentation or so, but this is fundamentally a good set of rules to work by. There's another sort of section here which we can look at, which is actually the actual user protection and protocol abuse environment and general environments, things which go wrong on our DNS. I talked a little bit about RPZ. Everybody familiar with what RPZ is? in terms of a format? That's a no then. RPZ is just a format of file which allows you to take a certain set of information, like a website, and turn around and say that actual information that's in there is just a list of names, and then what I can do is I can put it into a reputational database, and once I put it into that database, I can filter on it. And I can filter and turn around and say, it's inappropriate list for this name. And it's dynamic, and it commonly comes from a number of providers, Serval, Spamhaus, and a couple of the ones which we've worked a lot with. But they provide that feed in automatically. So they're looking at all of the actual bots that are out there on the network. They're looking at how to filter on them, and they're basically providing an updated feed in that environment. You can actually take the RPZ feed, and you can actually utilize it with host filtering and IP intelligence, and you can create a very, very powerful user protection environment. So you're protecting the user from any of the actual content that's going out there. Where's this commonly utilized? In the caching environment, so the transparent cache. Where is it commonly deployed? Actually, in the places like the Middle East, it's very heavily deployed. Everything is actually scanned and checked in that environment there. So it scales hugely to cover many countries very easily. Another one is quite often DNS tunneling and those components. If you actually have a packet and you're actually taking a look at what's going out onto the internet, it's very easy to create a packet which is a valid packet, but actually is taking data leakage, or it is actually a request for data and taking HTTP over DNS. So what we find regularly is people actually turn around and try and tunnel the actual requests. They have A records going out and text records coming back in. There is actually a very easy way to actually take this and actually look at the number of requests per user come in. So I turn around and say you can have 10 requests, you can have 50 requests per second. If you exceed that, what I'll do is I'll quarantine you. Okay? If you actually go over it, I'll warn you or log it as an information set. So you can choose to actually have per user endpoint checking on that environment. You can also take it a little bit further. So rather than actually taking a bit further, this is just a configuration screen, but it allows me to actually set up specific configurations here so that I can actually look at if I see lots of requests which have NX domain in it. I have lots of requests which actually are for the same domain on a regular basis. They are encrypted. Therefore, what should I do with those actual requests? Well, what I'll do is I'll actually either rate limit them or slow them down. And I can turn around and just configure that very simply and very easily so that actually I can manage those requests, those DNS abuse requests that are being put through the system. Why do you want to do this? Very simply, the problem normally isn't necessarily the DNS cache, but it's actually the actual connection between the cache and the resolver. That queue and how many people you have in that queue or requests going in there. And quite often you'll find attackers will actually try and fill that queue up rather quickly. Malware does it on a very, very good basis, but also DNS tunneling does it on a regular basis as well. So DNS tunneling enforcement is also very good and very easy to be able to get done with. This is one which I did recently for a customer. What they wanted to do was they actually wanted their queries to come in. They actually wanted then to actually go into the policy and charging rules function, and what they wanted to do was pull some attributes back, and those attributes said if they were actually allowed to have adult, family, or child environments based on their actual components there. So we're looking at their specific, not the IP address, but actually their contract environment set there. Then I can go into the blacklist, so I can go into RPZ lists, and I can go into IP reputational as well. And I can build for any of these environments an adult, a family, or a child type environment set there, and a deployment which allows you to actually go on. There's also an interesting way that you can actually also utilize this to actually mitigate DNS tunneling as well, because if you haven't got a contract, then you're not going to be able to get a DNS request through it at the same time. So there are newer ways to actually stop DNS tunneling as well. CapEx, OpEx, surely binds free. Come on in. Surely binds free in terms of that environment there. I just need to put it on a Linux box. Actually, one of the things there is that you can put it on a Linux box, but actually what's the cost of running it in terms of operating it? Okay. Also, how do you scale it? And how do you actually get around some of the CVEs which are coming out on a regular basis? Don't know if anybody's had to deal with the last 3 in July and August. But this is a pretty good representation of the bind versions. And the red ones are the ones which I would put in automatically. Green have got new features which you might like to utilize or put on. But on average, we're running at about 10 patches per year, guaranteed in terms of that environment. We've just had 3 in the last 2 months on that environment there. But generally, what you can do here is you can look at what actually it turns in terms of capital cost and operational cost, and the maintenance of it, and how often you actually maintain that cycle. Quite often what we do then is we look and compare, oops, come on. We commonly compare what a traditional infrastructure would look like in terms of that environment. This one was actually based out of Turkey, and they basically turned around and said, look, this is the DNS servers we have. We have it in a centralized environment. We'd like to distribute it, but when we distribute it, we want you to actually look at what the actual caching performance is going to be for the users. We also want to understand what the actual size of the actual deployment would be in terms of number of resolutions per second. We also want to have DNS tunneling mitigated. And so we had a long, long list of items which we needed to provide. And we needed to scale it up to millions of users and that request there. Well, that's pretty easy, actually, because we can do that very simply in terms of that environment and scale it out from there. They did this architecture about 2.5 years ago. And to date, we've actually gone back, we've reviewed it once, and actually we've just actually put an extra blade into the system to actually be able to give them another year or 2 years environment there. They've also taken a lot of the actual software which they were running, and they were running it all in software, and they've actually put it into a hardware platform component. What I mean by that is they're using some of the chips on board the actual platform to accelerate it. So actually, we reckon that they've got about another 2 years worth of actual performance left just on those 2 blades at the rate of growth that they have. So just sort of in summary, coming to a finish on this, if you accept that there is a large number of things which are driving the actual internet in terms of the DNS requests, both our handhelds, our connections, and also the websites that are out there are putting more DNS requests in there on a daily basis, then the Internet of Things is starting to grow massively and will grow and double over the next 2 to 3 years, guaranteed. The use cases, it's very simple. It's actually a cache or it's an authoritative environment. But actually what it means then is that we need to be able to scale those components. Think about an architectural change. When you're next looking at your DNS environment, what is the architecture that you're wanting to actually look at, and how do you want to scale it, and what features do you actually want in it at this moment in time? In terms of security, one of the things that I talk about is that Bind does a huge amount of features, but it's not got the scale and it's not got the security which is required. Certainly not longer term in that environment set there. So look at the actual way that you can actually make a DNS firewall, not a firewall for DNS, in terms of the actual design and architecture. When you look at user protection, you need to understand the attribute, not just the IP address. You need to understand who is behind it, what the phone number is, what the contract is, and you need to be able to reference that and make a decision based on that information, the content. Also, for those people that wish to utilize the protocol to do different things, things like malware attacks, malware management in terms of that environment there, or if you're looking at general protocol abuse of DNS tunneling, how do you stop those components there? Okay. Last one, and not least, is that if you're looking at what you've got already in terms of an architecture and components which may be bind, then it's a capital operation versus an operational cost versus a CapEx cost. And so that changes a complete environment set there. So with that in mind, I've still got about 5 minutes left. Okay, I've actually exhausted all my slides, but I thought I'd actually open it up to the floor to ask maybe 1 or 2 questions, maybe in English as well.